So having gone through the modification on this card a second time in the previous video, where I've now gone through and buzzed out how this was wired in and gotten the same results both times, I'm confident I can remove the mod and at some point put it back in if I need to. I've documented how this is hooked up, I've documented the jumper cuts, etc. So at this point I think I'm going to go ahead and remove this mod from the system. It's just not needed in the configuration I want to build towards, which is getting as close to the original system as possible. I don't plan on using that S100 memory card anytime soon. So anyhow, of course this begs the question, can I find glasses that I'm capable of working with? So the intent here, I've just tested the card. The card's gone in, the system operates, so I know in all my handling and stuff I haven't damaged the card. It's a practice that I strongly encourage. Before you modify something, make sure it's operational. Otherwise you don't know if the modification you made broke it or it was broken previously. And just because I have handled this card a lot, I am on an anti-static surface, but I'm not using a wrist strap. I probably should be. I don't know how sensitive the 8080 is, or even potentially the ROM is. But I haven't damaged it. It operates. So I feel pretty confident removing this mod. So what I'm going to do, where'd my pointer go? So what I'm going to do is go ahead and unsolder all the wires from this 4050 and just get them removed. I will then test again, and if it operates, I will put these original new jumpers in where these jumpers have been cut to get that back to factory. There's three of them here. There's the C1 to C2. Hopefully I got this in video. C1 to C2. There's this ground jumper here and this ground jumper here. And I'll get those back in as they originally were. I'll test again at that stage. Then I'm going to go ahead and unsolder this socket to look closer at, we talked about this in the previous video, this ground jumper here, and I'm wondering if this via has failed or if perhaps there's been a trace cut under there at some point. It's possible somebody did a trace cut here thinking they were going to need to use that inverter in this circuit and then didn't. That's possible. I've also realized something I want to document and I haven't done yet, is if we look at this LS240, there's these 6 pads that poke out here off 6 pins, and the same 6 poke out here, but they don't go anywhere. So I kind of think the intent of these 6 and the couple here around this one is to give you tie points if you wanted to use those inverters for something else, or not those, or those bus drivers for something else. They're also inverting bus drivers, so they could give you just an inverter as well. I don't believe these are tied to anything ground-wise, and I guess just because I'm suddenly curious, based on the conversation here, I could take a look at that. Are these just floating? We know, looking at the X-ray view of the board, that this guy was meant to be grounded, it looks like. There's the via to the pin to what looks to be a via that goes through to the ground. Again, I don't know that. I mean, that's the way it looks in that X-ray view. So let's get on the ground here. Oh, got to be in continuity mode if you expect it to make noise. Okay, so what's happened here is these 3 inputs over here are grounded. And that's proper technique. You either use a pull-up resistor to pull them high, or you ground these TTL inputs. And these are, I'm pretty sure, the outputs from those same 3 drivers are just floating. And so what's interesting is I don't see where those are strapped to ground. Oh, actually I do see. So we were looking at these 3 tie points here, and they're grounded. There's going to be foil on the other side of the board that comes to these 3 vias that grounds those 3 inputs. So again, if you wanted to, you could do trace cuts on the other side of the board here and then use those 3 inverters for something. the same way I think this trace was actually cut, and this was intended to be used for something else. Assuming there is a trace cut here on this input, I will most likely take a small piece of wrap wire kind of through the holes and just rebuild that trace. I'll have to look at what I have when I get the socket out, but step one is just simply the removal of this 4050. Get a bit of solder here on the tip. I let it idle too long there with dead solder on it. That's my fault. And this should just really be, where's my tweezers? There they are. Let me grab the tweezers. And we will just lift each one of these wires off one at a time. That's the 5-volt pickup, and that was actually wrapped around the pin of the filter cap, or the despiking cap sitting there. We'll just lift each one of these off one at a time. I can say while I'm doing this that my arms are in contact with the anti-static surface. You know, the static dissipative surface on the bench here. If you don't have, that was one of the jumpers, that's why that came off kind of weird. If you don't have a surface like that, I strongly recommend a proper wrist ground strap. It's properly connected. There should be a 1 mega ohm resistor between the ground strap and where you connect it to earth ground. Just because it reduces the possibility of static damage. It should be in frame. These two grounds that I've just removed these from where they were normally grounds before, I think are just more convenience there than required for the system to operate. This is the interrupt 10 and 20 connections. One of these was jumpered in place, one wasn't. I've also got that wire, which I believe picked up a ground point. And I've got one blue one here. Actually, I've got two left over here. This one's curious. Where did I just remove that from? Because that doesn't actually go to the chip. So that's curious. I missed that when I buzzed this out. So the question is what was that? Hopefully the pictures are good enough that I can decode that. I'm going to leave him attached for now. And that should really free this 4050. There was hot glue that glued that on, that luckily separated from the board just fine, and I've been using a little bit of electrical tape to hold him in place just to keep him from moving around and shorting things out. So the question is, where was this going? I wish I'd have checked a little closer before I removed that. I'll have to look at the photos. Let me get the drawing back in place here. So that actually came off of this pin right here. 3N, 1, 2, 3N, 1, 2, 3N. It actually came off of there, off of what I see is that. That is the LS438. So that has to do, I think that's the interrupt controller if I remember right. I could be wrong. Well, the 8238. Oh, that's the system controller that takes the data bus off the CPU and gets you the outputs where they're driven. Memory write, memory read, bus enable, those things come off of there. And that is pin, it should actually be pin 3, and it is. Pin 3 is data 2, that's interesting. So why would they have been picking data 2 up and sending it someplace? That's certainly a miss in my little bit of reverse engineering. I'm trying to remember if I noticed that jumper or not before. Let me go get my original set of notes. I'm surprised I missed this the second pass through. So let's see, I had a couple of notes on here. So there's the ground jumper from 8 to 11 on this guy. 8 to 11 doesn't make any sense there. Where's pin 1? Because that's actually 10 to 13. STB came in on pin 11 through a driver clock for M1. And that went to INTE, which is front panel, through pin 8. Well, I think I missed that wire in both passes through this. Well, hopefully the photos, they're pretty high-res photos, will have enough to be able to figure out where that wire came from. But for now, I'm going to go ahead and unsolder the other side here, just because I don't need it floating. Or it can potentially ground to somebody. I'm not going to put the jumpers in yet. They shouldn't be needed for just this base system, CPU and memory card to operate. This card's kind of a pain to get in. We looked at this earlier and the fix didn't take, where there's the connector from the front panel that comes in here. And this pin is ground, and the lead into that connector is really short. And if you remember, I bent the little clip pin up to hold it in the connector, and the problem is the lead on it, I think in the assembly manual calls for 4 inches, and it's probably closer to 2.5. What's in the system, and that lead keeps getting yanked out of the connector and doesn't stick. So I am going to go ahead and replace that lead from the front panel with something in the 4-inch length so that this connector stays solid. This is a ground, and without that pin from the front panel to ground is still coming through the bus to the system, and it still operates without that pin in there. And this pin really just the wire on this just goes back to a ground lug, actually, in the case build. It doesn't even go to the actual PC board for the front panel. So that's not critical, but it'll be something I will fix up here. So I know I'm off camera. Apologies for being off camera. But I'm back over at the H8. I'm not going to tape this or video this. I'm not going to be here that long to get this done. CPU cards plugged back in. That kind of floating ground lead we just discussed is not touching anything. This should come up and run just fine, and it does. If I go to register PC, I still see the top of RAM where it should be, 137377 octal. So removing that has not broken the system. Didn't expect it to. Again, apologies for being off camera there. Next thing I'm going to do is unsolder those 4 jumpers. boy. The little hand to solder pump is plugged up, as they typically are. Let's see if I can get it cleaned out here. I'm just going to go ahead and unsolder, remove as much solder as I can. I'm not sure I'm on camera here. I should have freshly tinned that tip. This guy and this guy. Might have worked better to heat and pull the leads out. I didn't do that. And it's the C1 to C2 down here, which is these two. Oh, that one cleared out very nice. That needs a bit of fresh solder. I should have honestly put fresh solder on all 6 of these before I hit them with the pump. So those two have cleared okay. These two, did I unsolder the wrong ones? I did. Ha! Ha! I unsoldered the wrong ones here. These are actually jumpers that are in place and correct. Let's resolder them. Wasn't paying enough attention when I flipped the board over. I actually think at this point I'm going to do what I should have done, and that's pull out the lead that I can. That way that hole will clear much easier without the lead in it. And that is actually 3 up from the bottom, and you can see now where just a bit of fresh solder, so those actually clear well. Oh, that's not going to help. Yes, that cleaned out very nice. I really need a new tip for this desoldering. This hand pump, it's rather worn out. I'm going to put a bit of fresh solder on this side. You can pretend like you didn't see me do this. Heat that up and go. Let's see if I can get the lead to just drop out, at least push through. Good. That one fell out and he's still very hot. This one hasn't fallen out yet. Still hasn't. Well, he's laying on the back of the board here, so. Lift that off of there. Clear these additional 2 holes out. That one didn't clean out really well. Well, 5 of the 6 actually he cleaned out sufficiently to get a jumper in there. So apologies for the interruption there. It was a phone call. One of the things we had talked about a little bit in the previous segment was this extra jumper wire that I hadn't seen to have documented, and I have gone back to my high-res photos and taken a look, and this photo here clearly shows where that wire went that we removed. So there's a jumper lead that runs around to this point here. So this is a case where the high-res photos paid off. And note that I took 10 different photos of the front and the back of the board and changed the camera angle just so I could get a little better view up underneath things. But this then clearly documents that wire I missed both times I went through the board. For the other wire I want to investigate where I think there's a cut trace or an open via, I also got a good photo of it. So I'm just showing these as an example of why documentation up front really helps. So with that talked about, I want to replace the 3 jumpers that were missed. I've cut some appropriate wire that I think is close to the gauge of the wire that was in there. I'm going to use this screwdriver to bend these around, and hopefully that'll just drop down in there. It looks like it's a pretty close match, and it does. It drops down in there rather nice. So in this case, the diameter of the screwdriver is really close, so I'll bend this one around as well. Let's see if I can get him in place. Actually, that hole there may give me a bit of trouble. Yeah, that one hole there needs to be cleaned up a bit. Pencil warm back up here. That tip got excessively dirty because I, during the phone call, docked the iron without wetting the tip. It's a bad habit of mine, and it affects the lifespan of the tip, of course. So that looks to be cleaned out much better. Let's get this wire loop in. And we have one more wire loop down here on C1 to C2, and just the same process. If I can get him to go in. That hole not clear, it is. He just doesn't want to agree with me. So I've got those set to about the same height as the others. And I'm going to go ahead and start by soldering these from the top just to hold them in place, and then I'll flip the board over, solder from the bottom. I don't need a lot of solder here, just enough to kind of tack them down. And then, of course, I will test the card again in this state before I do any more work. So we should now be able to actually solder these from the back side to get a little more reliable joint. That hooks these 2 grounds back up and hooks up that interrupt signal again back in the factory configuration. We'll need to use a little bit of alcohol to clean the flux up from this, although the flux isn't bad. Trim these. Jumper wires I used there were just simply, actually those were a little long, I'm going to take those down as well. Jumper wires I used, did I miss resoldering these 2? Are from a power resistor, so with a wire lead that looked very similar to the jumpers that were used before. these are longer than I would like. So really, I think that gets me back to the factory jumpers for this side of the board. The next step, of course, is to plug this guy in, give it a quick test, which I'm going to do now. So I'm going to step away from the camera for a second, but I'll try to keep yapping here. Of course, this assumes I can get things to plug together over here. I just don't have room to get this all in shot without positioning the camera. You can see that ground lead's not touching anything. And again, the system came up, hit register, stack pointer. Where's the stack pointer? And it jumps right out at me. Stack pointer, and again, the stack pointer is set to the correct address. So it's seen memory all the way to the top of memory. So what I'm going to do next is investigate this jumper here, and to do that I'm actually going to unsolder that socket. So to start that, I need to remove the 74LS240 from the socket, and there it is. And I'm going to have to break out the good desoldering tool. I'm going to actually use my HeathKit desoldering station for this, so I'll be back once it's warmed up. The first thing I'm going to do here is remove the little red jumper lead. Well, on one side just fell off. That's not super encouraging. I'm going to add a little bit of fresh solder to every pin here, just because that generally makes desoldering a little bit easier. And of course, we're getting into the point here where dwell time is important. If I spend too much time, I could lift a pad. At the same time, a little bit of fresh solder actually makes desoldering easier. So it's worth a little bit of time here to add the bits of solder. Actually got a bridge there, but I don't care at this point. Got the HeathKit here. It's warmed up. Let's just walk through these. Again, dwell time is important. I don't want to lift a pad doing this work. Those are coming out very nice, it looks like. Those all look cleaned out. Let's pry a bit up underneath there. There's a couple of solder joints that were still lightly tacked. So what we can see here at this point is that trace that I thought maybe had been cut has not been cut. So that pad there comes through to this pad, which is part of this ground here. So this comes around to pin 8 on this device. That is definitely a ground path. So the question is, why was that extra wire on there, and was it actually needed? And I guess I could have just ohmed it out, buzzed it out before I unsoldered, but I did actually want to see that pad. So the conjecture is this pad should still be grounded, and it's not, and that's really interesting. You can see the foil here on the top of the board. We can see we have continuity through to there. Oh, I am seeing continuity to ground. Okay, I'm not sure why that wire was there. It accomplished what the board already had laid out, and that is it jumpered around to ground. Do we have ground to here? No, this all checks out. I cannot explain what this wire was on there for. It seems completely unnecessary. If we get on the back of the board, in the same configuration as the photo, hopefully I can get this all in shot, we can see that one of the connections is this pin here and one was this pin here, and it's grounded. That wire really was doing absolutely nothing. So I have no idea why that was added. So, but see, I was curious to see if there had been a trace cut underneath here. So the next step in this is a single wipe socket. Looking at it, I really would prefer double wipe sockets or even machine pin. Let's see if I can pull one of the... Nope, I'm not going to get him to pull out. But see, these are single wipe sockets. They were really common. They were cheaper. They do lead to long-term reliability. So let me go dig around, see if I can find a higher quality socket to replace that with, since it's been removed, and I'll be back. So I went ahead and dug through my sockets. I don't have any machine pinned, but I do have a number of double wipe. I don't know how well this will show up on camera, but if you can see down inside of this socket here, there's metal both on the inside and the outside there, so the lead is making contact on both sides of the lead, whereas on this socket there's only metal on the inside. That's why this is a single wipe. Touches only one side of the pin, and this is a double wipe. It touches both sides of the pin. Double-sided are just definitely more reliable. So the socket's going to go in. It's going to drop right in. I have aligned the notch in the socket, the alignment notch, with the white alignment dot there on the PCB that indicates where pin 1 is. So that's correct. I will use my normal process for this, and that is just use a piece of blue painter's tape to hold that in place. I use blue painter's tape because it releases without leaving any residue behind. I will clean up my tip, tin it a bit. And I'm just going to tack 2 corners, hold the socket in place, remove the tape, and I will gently push up on the socket just to make sure it's flush, and it wasn't flush on that side. I felt it shift, and it was flush on that side. Quick visual look, the socket looks fine. And we just go ahead and solder him back in place. Again, keeping the dwell time to a minimum so I don't lift these pads. You can see the solder joint on this side I'm not pleased with. I'll go back and touch that one up. That was this guy right here. Could use just a little bit more solder. Notice that I'm also reflowing the pins that I tacked it down with, because I did do that heat and push to get the socket seated flush, and I pushed up on it kind of during the time the pencil was being removed, so it's possible to get a fractured solder joint or an unreliable one. I'm not wearing the best glasses for this work. Based on what I'm seeing here, there's one joint I want to touch again. It's this one here going to the ground bus. Because of the width of that copper, it's got a little bit higher thermal mass. So a little bit longer dwell times appropriate. That looks... Nope, I see another one I'm not happy with. It's a little better. Take the original chip, which is this LS240. We've got the pin 1 notch up to where the notch in the socket and on the board is. And we just simply reinsert him. And of course, the final step will be to plug the board back into the system and give this a test. I will actually do that on camera, rather than just step away and talk to it. So I'll be back in a moment. So the memory or the CPU card's back in the system. We've got the W8 or the H8 16 card previously, the 16K RAM card in place. I fully expect the system to power up, which it did. If we look at the register PC, we can see that it's set at the top of the what would that be, 24K, I believe, but that's the correct address for the top of the 16K RAM card, with its origin set at 040000. So at this point, we haven't damaged anything or put the system in an unstable condition, or at least in a non-operational condition. This card should be back in the factory, and I'm going to go ahead and enter the memory test program and just exercise the system a bit. So I want to go to memory address 040100. I want to do an alter, start changing bytes here. 041 160 040 260 37066 000. We should be at 110, and we are. 315 47 040 043 302. I should be at 115 106 040 006 101 040. I should be at 124, and I am. 004 064 76 270 312 135 040 166 000 315 147 040 3 302 125 040 303. We're almost done here. 121 040 172 254 300 173, and I should be at address 153, and I am. 255, and the last instruction 311. So we've got the code entered. I'm actually looking for my note here that had the settings for the addresses. You know, that byte you modify to set how deep the memory test will run. And of course, in the stack of stuff here, generated a lot of paper in this so far. There's what I'm after. So let's see, the address. So this is what I was looking for, was this note here that has these notes that tell me the byte to change for the ending address, and that is at address 041 360. Yeah. So if we go to memory 40360, that doesn't seem right. What have I got? This printout's really hard to read. It actually says 021260. That seems odd. Yeah, that's definitely not the right byte. Oh no, I'm completely reading the wrong thing. This is address 040103. No, that's correct. Why don't I have an 057 there? See, a 20021 there. Okay, I've obviously got something incorrect here. There should be an 041, 057, that doesn't make sense. 160, 040, 021, 260. This is the byte I'm worried about. Oh, 345. So why have I got a 137 there? I have a 137 there because the memory test I entered was from the WH8-16 manual, and it wants to test the full 16K. So it's already set to the correct bit pattern here to test 16K. So now if we go to register PC 0 alter 040 100, the starting address, and then if we monitor the BC, we'll see the bit pattern being written over here, and we run and we see the bit pattern being written over here. So that memory test is running. So I'd say at this point we have an operational system. I haven't made anything, broke anything or made anything worse than it was, so which is a good sign. So I think at this point this is going to kind of end what I'm going to be doing with the processor card at this point. A future video we'll be looking at the Org Zero mod. I'm going to have to either make my own version of the little card that requires, or see if I can find one. Either way, we will tackle that. But I really think the next thing we're going to look at in the video series will be this card right here, this serial I/O card that's got the cassette stuff on it. I'd like to be able to save some of these programs to cassette. I have not begun to look at this card to go through if the jumpers are all correct per factory. There's some insulation that's lifted off that jumper lead there just due to heat. I may replace that lead. Not real pleased with some of these. There's a lot of wire exposed there, and as I thought, that solder joint's completely cold. That wire just came loose from the TL signal, and actually it's actually socketed. Okay, so that wasn't a solder joint. There's actually a little socket on there that lead goes into. I'll work that a bit. I hadn't noticed these before where there's these socket pins. Anyhow, that's enough about this card. We'll let the memory test run here for a bit, and we'll talk soon.